So review for first celebration. And couple things. I sent an email this morning, but you can either take the celebration from 1 to 4 p.m. So this is for Tuesday. And I call it a celebration again because exam has such a wonderful fear factor for so many, and we have enough fear in our society. Or you can take it from 6 to 9 p.m. So traditionally, for 25 years, this was always a 2-hour exam, and most people finished in an hour and a half. I give the extra time because you either are going to have to print, which takes a few minutes, or some of you don't have a printer, in which case you don't have to write the question, but you're going to have to show your work and stuff. So that's kind of factored in there. And just from previous experience, having done this now for a year and a half, better or worse, the people who have to write stuff down, it doesn't actually take them longer. That's more an intrinsic thing of some of you dwell, and you really shouldn't be. So if you prepare and are ready to go, you should be able to finish in 2 hours, even with printing and everything. I also have the extra time built in because there is the calculator discrepancy that we run into, which is some of us have to do everything longhand and some of us hit a solve button. I actually find the people who have to do everything longhand traditionally get done faster because they've been doing all the work and working through everything. All right, so you will have to show up for Zoom. So either coming at 1 o'clock or before 1 o'clock or like 5 minutes before 6. Since I don't know who's going to be taking the exam with which time, you got to come to Zoom and I'm going to be emailing it to you. So especially for those of you who've been in my class, that is different. Where it always just posted because we all did it at the same time. So you'll have to be on Zoom. And then once you get it, you can sign off. I will stay on Zoom for the whole 3 hours. When you get done and you submit it, you have to come back to Zoom and make sure that I can view it because there is randomly an issue with somebody who doesn't upload or something happens. So Damon, just real quick for you, you guys have to come to Zoom to take the test. You don't have to stay on Zoom. It was a question that came up with the evening group. For the first celebration, I'm not going to babysit you guys. You just have to show up. I email it to whoever's here, and then you do it. And you sign a little statement about cheating. If there's any weird stuff that happens, then we go to babysitting for the next 2. So let's just have integrity. This isn't, yeah. I don't anticipate having any issues. The other question that came up, and I meant to do this before I started sharing the screen, but it was about what is due this week. So today, this is Monday, it's just your study set 4 and worksheet 4. Tuesday, the things that are due on Tuesday. So what's due on Tuesday is your lab 2, which was, I don't know what I called it, but it's the acidosis. And anything that's late. So if you still have some study sets or something, everybody has a blip. That's all supposed to be in by Tuesdays, so we're ready to move on. The only thing due Wednesday, then you kind of get a chance to take a breather. The only thing due Wednesday is your famous chemist. I will be asking you also on Wednesday when you want to do your presentations. Presentations are next week. They will be they're scheduled for Tuesday, so they'll be during the class time. But it's Major's birthday, so I'm also gonna hopefully get like 6 volunteers to be in Major's group, which is gonna be on Monday. So if you want to do your presentation on Monday and then not have to be here on Tuesday at all and go celebrate Major's birthday, however you want to celebrate it, just let me know. I'll be asking that on Wednesday. Friday, or no, let's talk about lab real quick. There's 2 more labs that I posted that are in the week 2 folder. And so there is another 7-day. So the lab so you'll have labs due Tuesdays and Friday. The lab that's going to be due next Tuesday is another 7-day one. So you'll have to start that by Wednesday. I'll remind you all hopefully tomorrow when I see you. There's a lab due Friday that's kitchen chemistry. It's the one kitchen chemistry. You'll have to get purple cabbage or red cabbage is what everybody calls it, even though it's purple, and make some purple cabbage soup. And anyway, follow the instructions. That's due Friday. You can do it before that and you'll have Friday off. But we do have class Wednesday and Thursday. Those are big classes. I know where we're going this week. So get caught up, be prepared for the exam, be here, and then you get a little bit of a breather going into Wednesday and Thursday. All right, so this is an exam from several years ago. And I did make the rough draft of your celebration, and it's similar to this. Keep in mind, the other thing I did want to mention, because everybody's all about the celebration, yeah, it is 80 points, but going into tomorrow, you should have 70 points. So you've had 4 study sets, 4 worksheets, and 2 labs. And that adds up to 70 points. And then your presentation paper on your famous chemist, that's 60 points. And being here present when we do presentations. So keep that in mind. It all evens out that the tests are just one part of your grade or the celebrations. All right, so this first one is a Hess's Law one. And to get credit, you will have to show me. It is all show your work, just like this. The test right now, the celebration is 5 pages. It might actually be 6 pages because I spread it out more to give you more space for those of you who like to print. All right. You're going to have to show how you change the reaction, how the reaction changes. And so if you flip the equation, you'll have to flip it. So you'll be showing all your work. The other thing, and I'll keep mentioning that as I go through, there's a lot of these questions. Like B or G, where it asks you to explain more for. There's a couple of you who must have gone to like Catholic school and had, like I did as a little girl, and the nuns like made you write complete sentences. You don't have to write like full sentences to explain, but you may. That's fine too. But you're going to be explaining like why the answers make sense or what's going on. So that's why we're doing this practice, to make sure you have the ideas. All right. This is our overall. This is what we're trying to get to. We do not change that. So the one that has the question mark. In my first equation, I see that I have the SNO2. It's on the reactant side. I have one of them. So I'm not going to do anything to step 1. It's good to go. In step 2, I see the carbon monoxide. And we have some problems. It's on the wrong side, so we're going to have to flip it. Step 2 is going to have to flip, and we're going to have to also double it because I need 2 of them. So we're going to flip and double. So go ahead and try that, and then figure out what you're going to do with your K values. Or you can just, oh, we have to get to our value to see that. I'm just looking ahead. Okay, so I'm going to do is flip it. So you have your H2O. If you're somebody who's watching this later at home, pause it every time I talk, try the problem, and then watch how I do it. So the CO, when you flip it, you can leave off the states of matter. So the H2O and the CO. So I like to flip first, and then I'm going to double it. Right, and then that just means I'm putting a 2 in front of each part here. So what do I do to K? Anybody?
Invert it.
You double it?
Oh yeah, double it.
Square it.
Or square it.
Both.
Yes. So what power would I take it to?
2.
No.
-2?
-2.
Negative
One-half.
2. Yes. So you can do it several different ways. I'm going to give Paul that point because he got it. Although that was like a group effort. This is why we don't do group tests, because you guys would all start like, oh, okay, he said to double it, and you know, but I actually like the answers. I love calling him Paul because I like the idea to have Peter and Paul in my class. I've never had that happen. That when you double it, you would take it to the second power. When you flip it, you take it to the negative exponent. The other way we could say it is 1 over K2 squared. What my final answer is going to be is you can either say K1 times K2 raised to the negative 2, or you could say K1 divided by K2 squared. That makes sense. It just depends how you think of the inverses. So we should get 13.5. Technically 2 sig figs because my K's only had 2, but 13. If you want to go with the 3 sig fig rule for everything, that's great. So now we're going to say, is a product or reactant favored and why? So looking at that K value, what does it mean?
Greater than 1.
Yeah, K, that's all I'm looking for. K is greater than 1. So if K is larger than 1, it's product favored. More explanation just because I'm the teacher. I'll do it in purple. K is always products over reactants. So realize that you guys came a long way in 1 week. K's, you know, it's a ratio. It's all about products over reactants. So a value greater than 1 means that this number on top, you have more products than reactants. All I need for the explanation is that K is greater than 1. For those of you who are brief, for those of you who like to write, I have more products than reactants, blah, 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 that's fine, but you don't have to do all that. All right, questions. You'll definitely see a Hess's law type problem. Number 2, Le Chatelier's. This is one of the big things we do in this class, so you'll see one of these. And here's our equation. And we're just saying how each one will shift it. So if we add nitrogen, it's going to move
Forward.
Yeah, just do arrows. Don't do lefts and rights. I've seen disastrous things happen when students insist on doing lefts and rights. One of the things we want to take note of, and I think I just remembered, yeah, we want to take note of this. We want to look at states of matter. So this happened on the lab that was due Friday. I think everybody got that in, so thank you. Is states of matter. If something's a solid or a liquid, cross them off. Solids and liquids have no impact on equilibrium. They have to be there. That's what equilibrium means, is that everything is present. But adding more of a solid or liquid, they're not part of our K expression. Now, aqueous, absolutely, they have an impact, and gases. All right, so unfortunately on this practice, I kept everything as gas. Up here, like this one, the tins would have crossed out in our K expression, so just a reminder of that. All right, if we remove the ammonia, ammonia is the product, it's going to shift forward. And so if you take something away, you move towards it. If you add something, you have to use it up. All right, looking at this delta H, that negative means it's exothermic. It does help to make notes to yourself as you're going along. So your heat, if we wanted to write it in, heat is a product. It's losing heat. It's releasing heat. We do a lot with exo and endo this term, and so if you've struggled with it some, it will be one of those things you'll never miss again. So if we increase the temperature, we're increasing the heat, and the heat is over here as a product. So it's same like, yeah. So if we're adding more heat, it's going to have to go reverse. You have to absorb that heat. So when you add heat, it always moves endothermic. Delta H's are always written for the forward reaction. By the way, I'm wearing my NOF again. If you wear your NOF for your test tomorrow, for your celebration, you get a bonus point. So somebody will. Damon might, because he's not driving yet. He'll find something. All right. So pressure. For temperature, we look at delta H. Is it exo or endo? For pressure, you're looking at moles, but only moles of the gas. So if you had a solid or liquid, that's why I say to cross them off. And again, if you can get these colored pens that are erasable, it does make a difference. There's a couple of people who started turning in things with color, and that's actually really wonderful to see. So nitrogen plus the 3 hydrogens, we have 4 moles. And on my product side, we have 2 moles. So if you increase the pressure, pressure is pushing. It means you're pushing it together. It's going to move towards the ammonia. It's going to move forward. It moves to the side with fewer moles. Volume is the opposite. So a large volume means you're giving it space to expand. So if we increase the volume, it's going to expand. And in that case, it would go reverse. All right, a catalyst. Nothing happens. Why?
Because it speeds up the reaction both ways.
Yes. Christian, were you out partying all weekend? Were you at a rave or something? You got quite the, or you just woke up? Maybe that's what it was.
Yeah,
I think you just woke up. Yeah, I just realized that. You always slept through my office hours last term. They were in the morning. Catalyst speeds up the reaction in both directions, so it has no overall effect on equilibrium. So no change. So here's another question. So if you get your name up on the board, by the way, you get a bonus point added to your test tomorrow. So here's a question for you. You only get 1 point. So Paul and Christian, you just have to kind of count to neon before you answer again. So give somebody else a chance. At equilibrium, what is equal?
The rate of the forward and reverse reactions.
Is. That is absolutely right. And that was a new voice. So I don't know who that was.
Oh, it's Perry.
Very awesome. Thank you. My mentor, by the way, in graduate school, his name was Perry, but it was a he.
Yeah, all the other Perrys I've met have been
Well,
male.
spelled this way, that's why the first day I was fascinated.
It's actually, it was like my grandmother's maiden name. That's how my parents chose it. Yeah.
Okay. I'm assuming you're English.
Yeah.
He's English. Yeah, I'm pretty sure Perry, that's where it comes from. All right. So now temperature and pressure. So high pressure doubled it. So we want high pressure shifted it forward. We want it to move forward. High temperature, it went the wrong way. So we want a low temperature. So high pressure, low temperature, and that would be, if we look at the temperature, we want the 25, so we can cross out the first 2 choices. And if we look at the pressure, we want the higher of the 2 pressures. So it looks like it's choice 3. Reminder, pressure and temperature are not related in Le Chatelier's principle. Temperature is all to do with if it's exo or endo. It's an intrinsic property of it, whereas pressure has to do with how much gas is present. All right. So then G, if we change the temperature, we're going back to the fact that it's exo. And this is where you want to make sure you read. I have to read also because often I wanted you to decrease the temperature. So if we decrease the temperature, it's going to move forward. It's going to move towards the heat because it's cold. So you're wanting to generate more heat. So it's going to move towards the side with the heat. A shift forward means you're going to increase the product. And since it's product over reactant, that's going to increase K. That's kind of the logic behind that. So again, you can just use arrows. It's exothermic, a low temperature shifts forward. So whenever a temperature is the only thing that will change the value, there we go, there's the question I was looking for, of K. The other ones, there's going to be an adjustment of all the other parts. So any other one, it will keep K constant. All right, and then finally, another F. Which ones will increase the hydrogen? So hydrogen's on the reactant side. So basically, I'm asking which ones will shift it reverse. Anytime it shifts reverse, you're going to get more nitrogen and more hydrogen. So we just go back and only one of them, C, was the only change that shifted it reverse. Any questions with Le Chatelier's?
So can we, if we remove the nitrogen, would that also?
It would have,
Would
yeah.
also-
If I had a question where I said removing the nitrogen, that would have shifted it reverse, and that would have also increased the hydrogen. Yeah.
Okay, so out of all the 5, like those, it would
Out
be
of
only
the
number
ones
2
that I
distinguished.
did, the only one was C. Yeah, but that's a really good question, Major. Thank you. All right, on number 3. So a lot of people miss this one. I did not give a lot of room. The key, and this is why you want to have a highlighter or something as you do this, you're at equilibrium. You don't need an ice chart for this. So you're not mixing anything. Ice chart is when we start by mixing. That's on the next page. So we're going to plug right into K. So reminder, you're showing your work. So you're going to start by writing your K expression. You can do it anywhere on this one. Usually we save the space under the equation for our ice chart, but on this one we don't need that. So K, and we show the products. Probably, you know, this, I think this was on one of your worksheets or one like this. The most, missed thing on this was everybody states their K right, and then they plug in haphazardlessly. We're doing a KC, so you have to be in molarity. So be careful of that. That's been one of the most missed things, like on a worksheet where you lose a quarter point or something, is you cannot use moles. All of this changes on Wednesday, and I'll explain why. But for right now in this class, because we're just getting this idea of how to work with equilibrium, how to work with pHs, so we're ready to add the next big step. You want to be in molarity. There is an exception for this celebration. Does anybody know what that exception is? If the
When you're
question,
working with KP and atmospheres, yeah.
that was Peter, right?
Yes.
Yeah, so if you're doing KP, and it will always say KP if it's working, the P is pressure, then you'll be in ATMs. If it just says K or says KC, KAs, KBs, KC, those are all molarity. So this is, we have a lot of P names in this class. Right, there's a whole bunch of M's too. So we just plug in, and so you can go back, you guys can all find that. State your formula, and then state how you plug in. Just make sure you get the right ones with that. Here's my SO3, and I had 2 liters. Remember to square. You can also write them underneath, but if you did, you're not doing an ice chart, you're just starting with E. Our SO2, so 0.5 moles per liter. That one is squared also. And then the oxygen is not squared. And you punch it in and you get a value for K. I gave only 2 sig figs. Again, if you want to just do 3 with everything, a reminder with sig figs, these zeros that are to the left of the non-zero are placeholders. I do not care if you show the 0 on the other side. I don't, of the other side of the decimal. You can also show it in scientific notation. That's just a preference. This value of K tells us what?
It's reactant favored.
Yeah, that K is less than 1. So it's favors the reactant. quick comment with this page and with that question is when I asked that up here on 1B or just now, that's just saying based on this value of K, it's at equilibrium, but it always is balanced one way or the other. Le Chatelier's is a different question. You're at equilibrium and it has to shift to keep that equilibrium. So what's going to happen? Any questions on the first page? For those of you watching at home, I do come up with a question at some point that you can email me, or those of you who are too shy to speak out loud. So you can all get a bonus point. And then you can all wear an off tomorrow. Because then you won't take yourself as seriously. And then I can say to you truly, when you stop taking yourself so seriously, and welcome to the human race. I think we should all start fashioning headphones. I like this. So many people have headphones. The ones you have major, my ears are so small, they fall out. But when I was in Chinese medical school, I have a degree in acupuncture. The teachers made fun of my ears because they're like little ears. And they were like, oh, you have bad luck. That's the whole thing in Asian cultures, that the size of the ears. Like Buddha has those big ears that, whatever. Nothing to do with the size of your ears. All right. I'm going to pause us for 5 minutes. I want you guys pick a question. Just try one of these questions. You're going to do ice charts on this page. So do an ice chart or just do your ice charts. I don't care. Try something. All right, I'm back. And you can keep going if you're getting the answers and kind of listen in the other ear. Well, the answer's right there, so I know it's a Q question, but there's my K value. We have 2 liters, and it tells us the flask is filled, which means we're mixing. So these are going to be initial values. 2.5 moles. We want to put it over the volume, so you want molarity. 1.5 moles and 1.0 moles. And you have all the initials. So all initials are given. That tells you it's a Q problem. And that's like when you get to celebrate. That's why it's called a celebration, because you're like, it's a Q problem. So you set up your Q just like your K expression. You state the expression, and then you'll show me how you plug in. So you can write your whole ice chart and then realize you don't need the C and E because you have the I. And you can also tell it's a Q problem because I don't ask you calculate K or calculate this. I ask what happens. Does this increase? Does that decrease? All right. So you can plug it in just like this, or you can find the molarities. And make sure, probably the most missed thing is people forgetting to cube or to square. The other thing I want to point out with actually all of these problems is however I give you the equation, that is how you keep it. Unless it's a Hess's law. In Hess's law, we flip them because we have to get there. But in this equation, I'm writing it as the NH3 is breaking down. It could also be written that the nitrogen and hydrogen are combining to make the NH3. So however I give the equation, that's how you write it. That gives you a value of Q. And then I recommend you'd have to, this is showing your work, you would state your K and your Q. My K is 0.036. This is 0.06. And so the Q is a greater number, which means it's going to shift reverse. So it has to, it actually doesn't shift, it moves in the reverse direction to become equilibrium, which happens really in that femtosecond. Now, the question asked, what happens to the hydrogen? So if it's moving reverse, that would mean that the hydrogen decreases. And so that's all I need to see for your explanation. Again, you can write sentences, but that's what I'm looking for. And then kind of back to the question Major had inferred on the previous one, it's shifting reverse. So the nitrogen and the hydrogen are both decreasing. The NH3 would increase. So it has to, or rather it's moving reverse to reach the point of equilibrium. The value is too big. So there must be too much product to start with. Questions with that? All right. So 1.2 moles SO3 introduced means that's my I, and 2 liters. I made it easy for myself while I'm doing this. And that's all it's telling me. So these are my zeros, which means it is going to shift, move forward. My change minus 2x plus 2x plus x. I did want to compliment you all that on your worksheets, you're showing your ice charts beautifully. So it is, and that's also why I give you the full 3 hours if you want to dwell for that long, that because some of you to show your work really nice. That's just our personality. All right, so we have to find the equilibrium amount. So this is going to be 0.6 minus 2x. This is going to be plus 2x. This is going to be plus x. The percent decomposes. That is my change. So the initial times the percent will equal the change. And a good percentage of you on your second worksheet, you had the answer right, but you lost a 1/4 point. And it said, please label the step. So you showed the step, but you need to state that above the step. So we have our initial amount, which is 0.6, which needs to be molarity, a reminder, times the percent. So this has to be our molarity. The percent, you have to change it, right, to 0.75. And we get a number. Which is 0.45. That is this change, which is 2x in this case, because the one that we're measuring, the SO3, is 2x. So to find x for the oxygen, you would have to cut that in half. This will be 0.45. This will be 0.225. And then this will be 0.15, it looks like. Questions with the ice chart? So this will allow us to come down here and finish it. And then you would state your K expression and plug in and solve, and questions with that. All right. Now, something interesting that's happened here, because usually like on your worksheets and your study sets, the numbers, the values of Ks can be huge or really small. These have all been really nice numbers, and that does happen sometimes, but just kind of go with it. And again, when you're taking your celebration, I will be on Zoom. I only allow 1 person on at a time. So if you're in the waiting room, just stay there. You do have a time limit how long you can stay on with. If somebody's in the waiting room, I'll tell you, hey, we have to wrap this up. And so just come on and ask and say, I'm not going to tell you, yes, you have your answer right and stuff, but yeah, you can't ask that. All right, so on our next one, oh good, I did this. So we fill it with 0.5 ATMs of C. And this was a question somebody had asked me. So you can start on the product side. That's the wonderful thing about equilibrium. That would mean my zeros are on the reactant side. So this is going to have to move in the reverse direction, which means my minus 2x is on the product side. My plus x's are on the reactant side. So the minus can be on the reactant or the product side. It's just however it works out. And so at equilibrium, this is x, and this is 0.5 minus 2x. We're going to keep it in ATMs because it's a KP. You'll state your K expression. So you're always stating your K expression. We plug in. I gave you a value for KP. And this one I'm writing out because I want to emphasize you have x times x, which is x squared. Now, at this point, one of two things happen. You are either going to say solved with a TI-89 or whatever with TI blah, 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 in which case you're going to give me two values. So if you are somebody who has that solve function on your Inspire or whatever you are solving with, you will give me two values here, and then you'll circle the one that you're going to use. So if there's a negative value, that's not possible. If they're both positives, usually the larger one, or always the larger one, is too large that you can't subtract that. So if you're doing that, you need to tell me on this type of problem that you did that. If you don't have that, then you're either going to hopefully have room that you're going to rearrange and solve. It is not a quadratic. You can't cross out the squares, but you can take a square root. You do have to take a square root of both sides. I can see who's having to do their work and who has solved with the TI. And I take that into account. So even with the worksheets, because some of you, it's obvious that you're working it through, which is wonderful. It's actually wonderful for your brain cells. And then you rearrange and you solve and you get your X value, which I did at some point. I'm not going to go through all my algebra. And then you'll find each one of these and add them together. So the P total, all right. I am aware of this discrepancy with calculators. So if you have a square in the problem, you're going to be able to square root it out, or else you're not going to have a square in the other piece. There should be some way to deal with it. That's where you're going to add your pressure of A plus your pressure of B plus your pressure of C together. So some of you got away with, there was, you got to show all your work in a way that's systematic. So if you want, if you can always, if you're printing and you're having to go through this, you can do where you say, hey, see attached page. And you would say question number 6, additional work, and then come back on here and you tell me X equals whatever it was. That's going to be in your ATMs, and then you add them all together, and that should give us the 0.5. Questions from this page?
I just want to make sure I understand the rearranging right. Which is times whatever the square root of the 0.15 times the x, and then we switch
Yes.
around. Okay,
Yes.
sweet. I just want to make sure that was all right.
Then you'd have to add the 2x to the side, right? Because it's minus 2x, and then you'd have to divide by whatever that number is. And I do have my numbers here, maybe. Oh, sorry. So you should find that your X value, I just have one of them, is 0.209 ATMs when you solve. So ideally, if you did the algebra, your study sets are good practice. I would tell you to, redo your study sets or go back and walk through the notes and stuff. Anybody else have a question from it's everything that we've covered so far. The other thing, and I think Major asked me this question, I think it was during my office hours. I sent out an email today, and it also says this on that if you want, if you're watching the videos, it's like my cover slide on there there are these stone towers. If you go hiking, people build them all the time. It's a Zen thing, and you stack stones. Most people can get to 5 or even more than that. I can't get past 2. So, but if you would like to take a break from all of this, you have until Sunday morning, early Sunday morning, to build one. You gotta take a picture. You have to be in the picture and email it to me. Whoever gets the most elegant one or the tallest one or whatever, yeah, I'll give you 2 bonus points for making a good effort. It has to be a good effort. So more than 2, more than your teacher doesn't get a bonus point on this. All right, so we move to acids and bases. And that page is done. So again, my goal for that first week of class, this first celebration, is that you should feel okay with equilibrium. It was a brand new concept 1 week ago. This idea that reactions really do go both ways and these K expressions. And now you should be able to, like, you can write a K expression, no problem. And then this idea of pH, it really needs to be where you can work with these pH formulas very confidently. So going back over your study set 4 is due today, and I will go through it. And a lot of this is also on study set 4. So this should hopefully fill in some of the questions that you may not have had. I also will be mentioning, I have mentioned that, so it's all behind me on the board, or what I would do, mine's all in my brain, condense all your stuff so it's on one page. So have your strong acids, because when we see the strong acids, what is special about strong acids?
It's only one-sided reaction.
They always
Yeah, it's a one-way reaction. And so the other thing, because it's a one-way reaction, there's no K value. There's no Ka. You're just plugging right into the pH. So strong acids, the only strong base we're going to work with is the hydroxides, NaOH, KOH, something like that. All right. I will tell you, there's true false also on your study set. This used to be on the exam. This was, like I said, a previous exam. I have learned that true and false really are a disaster for half of you for some reason. I don't know why. And I think and actually some of you are nodding your heads and told me you overthink. And so it's like you have it and then you decide, no, it's a trick question and stuff. So I actually avoid true and false on an exam type of situation, just because some of you do this it's fascinating to me, but they do actually serve a purpose. There are, like I said, a lot of these short answers explaining. And so as I go through the true false, or you can do, for true, you can do a happy face, sad face. Sometimes that works. I'm going to go through some explanations too, to refine, to make sure we've got this. Because again, on Wednesday, we move on. All right. So this first one this used to be a question on our final. Chemistry is fun, and it was true, false. And so 99% of the class would write true, which was what my answer key had. And then there'd always be that one, like, I don't know what kind of student who would say, no, they had a grudge about the class for some reason. All right. This is a trick question. So this very first one, the C, it is false. Anybody? This should be the one that you can email me. Email me why it's false. If your name's on the board, you can email me, but you already got your point. You'll have to give me an example. Actually, this may disappear in a moment because the answer is actually later on. All right. How about this one? This one is false. There are examples. Anybody can give me an example?
Ammonia.
Yeah, so NH3. Any of the nitrogen ones, they're neutral charge. So you have to be careful with the term neutral. And so I always say in here, neutral charge. It doesn't have a charge, but it is a base. So that's why that is false. Now, a lot of things, not everything with a negative charge, though, is a base either. And we'll see that when we get, that was like the question, Max, you had asked me before class. That's on the next page. All right, on E. E is true. When you dilute it, you change the concentration. You change the molarity. And it's all about, weaks are all about Ka values. And what we're plugging into Ka values, into Kc values, into Kb values is molarity. You change the molarity, you're going to get a different answer. So that is, I think that question shows up also on your study set. All right, M was just something we went over, and it's from the two different sides of the periodic table. I mean, you can just find it in your notes and say, where is it? But what was the name of the 1As and the 2As? The family name is alkali metals, alkali earth metals, and that is because the metals act as bases. So they form the basic solution. So NaOH, KOH. This is as a metal. That's the key. Non-metals would be the opposite. They're going to form acidic solutions. So that would be false. If you had to change any word, you made it false. All right. I is false. Why? Just had to change one word.
It's the conjugate
The-
acid.
It is the conjugate. This is the conjugate acid. So this picked up a hydrogen. So it gained a hydrogen. And that makes it the conjugate acid. Again, it gains one. We only change it by one hydrogen. So that's why it's false. Switch back to our purple to find more pens. S is false. Nitrogens. See the nitrogens, and there's no, it's a neutral charge. They're going to be a base. That holds true by by all their definitions of acids and base. All right. How about T? That is true. Yeah, another true one. So amphiprotic, amphi means it has, oh no, I'm sorry. I read the question wrong. That is not, no happy face. Wow, they're all false. It's not. Amphiprotic, I was thinking polyprotic. It's polyprotic. It has multiple hydrogens to donate. It is not amphiprotic because it's only an acid. So that's sad, too bad. So it was a polyprotic. See, that's why I avoid true false, because when we're in that test mode, our brains think different. All right, R is the true one. Yes. That's actually, and this is for Devin who's out there, this is the definition. Devin had wanted like the proofs and the mathematics. It all comes down to this, that acidic just means you have more hydronium than hydroxide. So every water-based solution, there is a ratio of hydronium to hydroxide. If they're equal, that would be neutral pH. But there's always a balance of one to the other. So acidic just means there's more hydronium. All right, these next two are what you're doing in the lab that's due Friday. You can do it before that. It's a kitchen chemistry. The household cleaners are alkaline. I did actually, so Friday's lab, there is a video, I think it's like 25 minutes that I made, and the first 10 minutes actually goes through some of the background stuff about acids, bases. So you might want to watch at least the first half of that video. And then the second half just talks more about the lab and stuff. But it also, the other thing about the lab, the video, besides having some introduction stuff about acids and bases and the definitions and conjugate acid and conjugate base, some of the questions some of you have been asking, it also mentions, I think, about 8 different famous chemists. So if you're somebody who hasn't found a famous chemist, it might spark an idea for you, because none of the ones I mentioned in there have been picked yet by this class. All right, and I've mentioned this before, that fruits and vegetables are acidic, and the term acid actually is the word sour. So that is true. So we had 3 true in a row. Right. S is false. And that has to do with the definition of, it is a Lewis acid. And so a Lewis acid accepts electrons. And so boron's missing electrons, and so it can act as an acid. So Lewis, Gilbert Lewis, he looked at everything in terms of electrons rather than the protons. All right, the next one is false. Why?
It can only donate that hydrogen on the end.
It can only, yes, this is the only hydrogen. It is monoprotic. But why? Why are the other hydrogens? What about these hydrogens that are on the carbon? Why can't it donate those?
Carbon forms 4 bonds.
Carbon forms 4 bonds, but it's more than that. When carbon bonds with hydrogen, what type of bond is that?
Non-polar.
Yeah, these are non-polar. Acids have to have an extremely polar bond. There has to be a pull so you can pull the hydrogen off. You can't pull those hydrogens off. And that's why on worksheet 3, a lot of you missed a 1/4 of a point. It was actually a nitrogen compound, and when you added to make the conjugate, you have to add the hydrogen to the nitrogen, because that's where it goes. The carbon won't pick up anymore. It's already maxed out. All right, U is true. So this is a strong acid. It's one of the 6 strong, so we would just do negative log of 12. This is a question I asked in one of the videos. Nobody ever emailed me, but there's our answer. If you have a concentration greater than 1 molar, in fact, if you have a concentration, if your acid concentration is 1 molar, your pH is going to be 0, because the log of 1 is 0. If you get a concentration greater than 1, you actually will end up with a negative pH. It has to do with how logs work. My sister got a degree in pharmacy like 30 years ago. That's not what she does anymore, but this was a question on like one of their big pharmacy exams, and the whole class missed it. Everybody wrote like these long, elaborate answers, and all they were looking for was that you understood the idea of logs. So if you have a concentration of 1 molar, your pH will be 0. But so I did mention this, I guess last Wednesday in the video. So the pH scale does not go from 1 to 14. It actually could have a negative. This would be extremely acidic. You would burn your hand, and because it's highly concentrated, and it can actually go above 14 if the concentration of the base is above a 1. All right, these two were, I covered this right at the end of the lecture on Thursday. So here the HI is stronger, so that would be false. So as we increase the size, it's easier to remove. So if there's no oxygens involved, it was looking just at the halogens, easier to pull off the hydrogen. So in this case, we're not looking at electronegativity because the size of the atom actually makes a big difference because we're adding shell layers. And then the very last one is true, that as you add more oxygens, there's more pull. It actually has a fancy name like inductive effect or something. And so this one, so there's more oxygens, there's more pull, and again, it's easier to remove the hydrogen. Just a reminder, you're not removing hydrogen, you're removing hydrogen ion. Any questions kind of with those? Again, that's just more, I left this on here as true false because it helps refine some of the terminology. We see these again on the study set. I'll be going over at 6 o'clock, some or a similar one. All right. So I promised like a mini chart. So the chart that was in your notes. You should not need it for the test. I give the KAs that I want us to all have the same KA or KB values. So this is important because they all had to have the same concentration to start with, and which will have the lowest pH. So anybody want to answer that one?
The methyl.
Okay.
No, we're not doing acids, we're doing bases. So the weakest base, so the strongest base, which was the methylamine, is going to have the highest pH, right? Because that's what it means to be a base, is your pH is higher. So the weakest base is going to have the lowest pH. And so that was the aniline. I'm wondering if they're all aniline. All right, you can sing Sweet Aniline here if you want. Which base? Okay, so POH. You have a 50-50 chance. It's not going to be the monkey in the middle. So the aniline is our weakest base. And actually, for full credit there, we know it's the weakest base because it has the lowest KB. So the lower the KB, the weaker the base, the lower the pH. Remember when we do acids, we did one with acids, and I think the one on the study set is that POH is the opposite. The lower the POH, the stronger the base. So pH and POH always complement each other like yin yang. So whichever one's stronger. So as pH goes up, POH drops. So the lowest POH will be the strongest base. So that would be the highest KB. And that one is the methylamine. Questions with that? All right, which one has the strongest conjugate acid? You got 50-50. You can just flip a coin here. It's going to be whichever one is the weaker the base, the stronger the conjugate. Oops. So the weakest one was the aniline. So in case Devin watches this, the proof for A and B is that cute little formula that pH plus POH always equals the magic number 14, right? So if one goes up, the other one drops. And that's the same idea here that, and we use this formula, we use both of these quite a bit, that the Ka times the Kb is, this is always for an acid and its conjugate base. So as one goes up, the other goes down. So the weaker the base, the stronger the conjugate acid. They're always partners in this. All right. And then hopefully, if nothing else, that little P is not as frightening as it might have been a couple days ago before the weekend. That little P, or if it was, now you're going, oh, that's all it means. Whenever you see the little P, it means negative log, in this case of the KB. So PKB means that, like POH would mean the negative log of the OH. And I talked about this. So because it's a negative log, as you increase the KB, you will decrease the PKB. It has to do with how log functions work. So that you'll have to think about and remind yourself. So if I'm looking for the largest PKB, that will be the smallest KB. And so that's the weakest. So it's the aniline again. And a reminder, so this is, so if I ask you to solve for pH, POH, pKa, pKb, So if I'm asking you for the P value, you're going to do, your final step will be do the negative log of that. It was a question that came up beforehand. If you're given the PKB, sorry. I'm so happy in the fall when I don't have to like try to write and see if everybody can. But then they're like right there in the classroom and they'll tell me they can't see. They're not all muted. I might have to get muzzles for my whole class. So it's like this, all muted. All right. Oh, even better, we all get to wear masks. If you're given the PKB or the pH or the POH or the pKa, if you're given something with the P, to get rid of the P, you do 10 to the power. And that will get rid of the P and get you out to the normal zone of stuff. So keep that in mind. And that is really the big purpose of today's study set, as was the last study set and worksheet. So today's study set and worksheet, hopefully you're feeling more comfortable at changing around that. Oh, all right, if it wants PKB, your last step is to change its negative log. If I give you a PKB, you just pull it out and use the KB. All right, and now we're going to do reactions. On worksheet 3, the most missed like quarter point here, there, and everywhere was writing your reactions. So write them with care. The math you guys can do. You got it. You want to look for strongs. So that is a strong acid. We're looking for a strong. Why?
It's a one-way reaction.
It is. Was that Perry again?
Yeah.
Okay. I'm trying to get like
Do I
recognized.
not show up or like pop up?
No.
Oh.
Nope. Only Major does. It's the bizarrest thing. He's the only one that his picture will come up there. I don't know why. It used to be in the fall. It always showed me, and then it doesn't. All right. So that is a strong acid. So have your little note card of your strong acids because you want to look for them. The other key with this is you only move one hydrogen. One hydrogen moves. So the acid donates a hydrogen to the base. So it's going to go to HSO4. And the charge changes. That's a small piece of it, getting your charges right, but you were neutral. You're now going to have a charge on the other side. This is the conjugate base. So the acid becomes a conjugate base. The strong acid, only one arrow. So my base is going to gain the hydrogen. So we go to H2CO3, which is the conjugate acid. Any comments, questions? Somebody's got to say something.
Isn't it supposed to have a positive charge, not a negative charge, since it's a loss of hydrogen?
Hydrogens are protons, so they're positive. So when you lose a positive, you become negative. This one was negative. Yeah. So when it gained, it became neutral. Yeah, great question. Again, anybody else? Nobody's catching it.
Don't you need to break up the carbonic acid to CO2 and water?
Yeah, who is that you, Juan? Yeah. Your voice is really weak. It's like you're a little chicken there talking to me. Yeah, so the carbonic acid, this is actually perfect for me to mention something. So if you end up with that as a product, it does actually break down into H2O and CO2. So again, there's going to be another 7-day lab, 7-day inspiration lab that you have to start by Wednesday. It's there, so you can start it sooner than that. And it has to do with this. And so our respiration affects our pH. And there's a video. It explains my reasoning. behind the lab. Well, not all of it, but most of it. It's quite the jump of wonderment. All right, but how fast you breathe. So this is happened to my dad like many years ago, and he had to go in. He went through a neurological and slowly degraded, but he had fallen, and unfortunately the doctor sent him to get an x-ray, and they sent him to the hospital instead of the x-ray place. And he sat in the emergency room for 4 hours, which was not a condition my dad needed to do. And in there, he got exposed to MRSA. So he ended up getting a kidney infection. And this whole time I'm on the train going across the country. So by the time I get there 3 days later, you see your mom, you give your mom a hug, and my mom just whispers, "Go see your dad, he's in bed." And you're just like, that's my greeting. Like, this is like, and so I go upstairs, and the first word my dad says, and my dad is like the quietest man in the world, not a drama king. He's like, "Call 911. And I'm like going, you waited till I got here to call 911. But so he and I'd never want to ride an ambulance again in my life. Not a fun ride. But it was basically that his kidneys had shut down, and he had uncontrollable, what has to do with this, he had uncontrollable hiccups. So he's like trying to talk to me, and he has hiccups because since his kidneys weren't working, he was in acidosis, and his body is desperately trying to get rid of CO2. And so when somebody has uncontrollable hiccups, it's usually because they're eating with their mouth open. And so they swallowed air, or they use straws. It's the thing at all your guys' coffee places, why you use straws. Anyway, but somebody who really has unexplained hiccups all the time, it can be a sign of acidosis, and their body is trying to get rid of gulps of CO2 in a hiccup. All right, the next one, the key, I sometimes tell this story is to just distract for a moment so you can do the next one. You see the COOH? This is an acid. It is a weak acid. Organic acids are always weak, which means 2 arrows. All right, that's the hydrogen that comes off, because again, these other hydrogens are non-polar. They don't pull off. So this hydrogen, you don't have to show the arrow, but it's going to move over to the water. The water would be our base. Make sure you label all your parts. So C6H5, and you can write COO, or you can write CO2 negative. You can combine, but we do want to show this part separate and special. That's my conjugate base. So the acid becomes the conjugate base, and the water gained a hydrogen, so it's now the conjugate acid. And if you don't see a strong, you're looking for a hydronium or hydroxide, or you'll have to have that table from our notes. So it's going to favors the reverse. You just show the arrow because of the hydronium there. Any questions from that whole page? All right. One more page. We're in good shape. So I'm going to stop again. If you're watching at home, pause me, work on this. So while people are coming back, just the syllabus, which is posted, but because I've had several emails and people asking, so as I went through, this is much easier than what I had on the board. So this is today. We're on the 2nd of August. So your study set, 6 o'clock, I'll go over in your worksheet. So when we get done here, I always do stay after. I just have to take a break from 4 to 5 so I can decompress. And then, so for those, if I absolutely come and have me go over the worksheet with you. Half the class is, get full points on the worksheet. Come and ask questions. If it's old worksheets, please come and ask. And I'll have the same office hours tomorrow. If you're taking the exam at the later time tomorrow, you are welcome to come earlier, like in the afternoon, to ask questions. Just realize there's only one person I'll have on at a time. But if you have questions you want to ask on worksheets and stuff, because several people have asked me this, the acidosis lab, which is the 7-day change that you made to your diet, that is due by tomorrow, ideally. So ideally you started by last Wednesday. You do have to make a healthy recipe. It can be as simple or as complicated as you want to do. I had that website that I gave you the link to, and then you're supposed to watch one of those videos. It does say here you have to start the next one. That actually has to be started by Wednesday because it's due next Tuesday. So it's 7 days again. There's 3 parts to that lab. 2 parts are 7 days. So make sure you look at the lab. I also talk about it in the thing. And Major's birthday again's next Tuesday. So I will be doing lecture Monday, but some of you will be doing presentations also. Yeah. All right. Let's do this. I just have my answers, so I don't have to do everything. So the pH, this one. This is a strong base. When you see that hydroxide, this is not KB. No KB value. This question is always, for some reason, the stumper on there. So with me telling you that, maybe you all get it. So barium hydroxide, sodium hydroxide, magnesium hydroxide, I think was the one on the worksheet. So the hydroxides means we're going to do this. Usually I start you with mass. See, that changed the grams to moles, but I started you with moles per liter, which we want. But the key is here, this is barium hydroxide. And to plug into the pH, we need a mole to mole ratio. So for every 1 mole of barium hydroxide, I think there was one on the study set that I went through on Thursday, study set 3, you will have 2 moles of hydroxide. And so the 0.0826 is our molarity. A reminder, all the pH formulas, they work with molarity, moles per liter. So if I start you with mass, you have to do mass over the volume to get to moles per liter. This is your OH. So this is really my first step. Our second step is that we would do negative log of the OH, which you could fit in there. That gives us our POH, and then pH plus POH equals 14. So that's where I got the number. The other thing I want to point out about this, and I wrote a note to many of you, when you give your pHs, please give them to 2 decimal places, to the 100th. It is a log function, and the rules for sig figs actually are different. This number, 12.92, actually has 2 sig figs. So the rule for functions is the place value is the number of sig figs. So there we go. So just give them always the 2 sig figs. That becomes really important. All right, this just tells us we have a weak acid. There's our pH. So 10, so the negative pH will give me my hydronium. Okay, so that's my first step. My second step is we're going to solve for pKa. So Ka equals hydronium times the conjugate base over the acid. You're going to state your formula. This number is going to go into both of those. So for this celebration, the top 2 numbers are the same. It's an x squared. And then this is my acid concentration. So we would have, you can find what the hydrogen concentration is, or you can just plug it in like this, 10 to negative 4.30 squared over the 0.025, and that will give us the Ka. Our third step would be negative log of the Ka value, whatever that number is, will equal the pKa. Apparently, you get, it must be 10 to negative 7, so 7 is our pKa. That does not mean it's neutral. That's just what the value is. Questions? All right. Ka, pH. So we state our formula. Ka equals the hydronium times the conjugate base over the acid. So, and it looked like, if I remember correctly, on worksheet 3, you all were stating everything beautifully. So just keep it up. Again, that's why I don't like multiple choice. I want to see that you can show your work. This is going to be x squared over the 0.34. We're ignoring the minus x in the denominator for all of these because it's always so small. The numbers I'm going to give you, it's going to be small enough we can always ignore that. I gave you the Ka values, and I do that on the exam, so you don't need to worry. We solve for x. This step becomes really important. Always state what your x means. Is it hydronium or hydroxide? If it is Ka, it is going to be hydronium. If it's Kb, it's going to be hydroxide. You want to do that so you recognize if you're ready to go right to pH or if you're going to be at POH. So negative log of x will be my pH, which we get 1.81. Just for those of you who worked it out, oh, I don't know what the number is for my x, but you have the idea. For percent ionization, the percent is the change over the initial times 100. Or we can say the percent equals x over the acid times 100, if you prefer that. So it's a change over initial. It's just like the one we did on that decomposition one. All right, now we get to the salts. So we're going to cross out some things first. Bromine is neutral because it's the conjugate base of a strong acid. So no effect on pH. 1As and 2As, no effect on pH. Iodine, again, conjugate base of a strong acid. So if you cross them both out, and this one was a 1A. So 1As and 2As, they don't form complexes. This guy is neutral because you cross both out. Here, cation, if you're left with the cation, this is going to be acidic. And again, there was somebody who was asking me, why is that? It has to do with Dr. Russell's specialty, transition elements. Are going to be transition element ions, I should say, which are always going to be positive. They form hydroxide complexes. So what they're doing is they're pulling the hydroxide out of the water. They have such a high attraction for the hydroxide. They pull the hydroxide out of the water and you're left with lots of hydrogens or hydroniums. And that's why you end up as an acidic environment, because these guys are so good at that. The 1As and 2As can't do that. It's the d orbitals. So transition elements have d orbitals. I think it's next Wednesday, next Thursday, we'll talk. I do a lecture on the complexes. All right, on this one, this is going to be that we'll see that anions are going to be weak bases. Again, the exception is the conjugates of the strongs. So this guy is, sorry, it's hard, I wrote a lot. This one's acidic. This is going to be basic, or pH above 7, pH below 7. And then for D, you need the chart. So the NH4, we'll look up the Ka and compare. This is, some people are asking me about and compare to the Kb. So we look up the Ka for the NH4, we look up the Kb for the F negative, because we can't cross either one out. The bonus on the worksheet today, that's pretty much what it is. I mean, I tell you to do that, and I give you the Kas and Kbs, and you're just comparing it. If the Ka is larger, it's an acid. If the Kb is larger, it's going to be a basic solution. All right, then we get to 13. So there's 2 of these on the worksheet. There's 2 of these on the study set. That when we're dealing with the salts, there's always a flip-flop that happens. So it's going to talk to you about saccharin. I think this is actually the one that's on the study set. And it's going to tell you it's a weak acid. We know that because the pKa value is given. But then they don't actually give it to you as saccharin. What's sweet and low, what's in the pink packet at restaurants, it's a carcinogen, by the way. They gave tons of it, like literally tons to rats. It's all they gave them. And the rats got cancer, bladder cancer. This is back in the 70s, so they took it off the market, but now it's back out there. That's not actually the evil behind these artificial sweeteners. Artificial sweeteners cause diabetes. Lovely, because they've been marketing it as for people who are diabetic. It actually exasperates it. It destroys your microbiome in your gut. The studies are out there, but we don't know that. A vaccine is not going to protect you from artificial crap. Just not eating the artificial crap will protect you. All right, 5 grams of sodium saccharide and 250. So suddenly it's talking about the sodium saccharide. So we have to make it into sodium saccharide. So this is the formula. Again, the study sets, go back and look over your study sets. This is the acid, but we want to make it into sodium. The sodium can't just add on. The sodium has to replace something. So you're going to have to cross off the hydrogen and add the sodium. So it's replacing that hydrogen. Now it's no longer an acid, it's the conjugate base. It's a base, which means you cannot use Ka. You must use Kb. So when you see these ions or salt, the term salt to a chemist just means ionic situation, that it flips. And so you'll see one of these and you just flip it. So we're going to go, I'm just going to walk through the steps. What I do for step 1 is I just do the pKa plus the pKb equals 14. That will give me my pKb, right? So that must be what, 11.68? Yeah. My second step is 10 to negative pKb will give me my Kb value. So I have to find my Kb value from my Ka, or vice versa, depending on what happens. So on the worksheet, I think it's the last 2 questions. You have an acid, you have to change it to the base. We need this formula. We need the whole thing. And then you can plug right into Kb if you want. You're going to state, so instead of hydronium, it's hydroxide. Instead of conjugate base, it's conjugate acid over the base. It is an x² problem. And we need this number. So you can do it all in one setup. I like to do it that way, or you can break it as a separate step and do it up here. I'm going to do it as one setup because I don't think I ever showed you doing that. So we have 5.0 grams of the sodium saccharide. This has to be molarity. so over the volume. But again, you can do this as a separate step up here and then show it coming in here. We have to change the grams to moles. Now, when we just did this previous question up here, number 12, I said the 1A's and 2A's, you ignore them. They don't affect pH, except when you're starting with mass, grams, you have to keep them in there because it's not aqueous yet. So when we add up the mass, we have to add the whole thing up. And so it should be somewhere around 205, it looks like. And then your milliliters to liters, however you set that step up. I do want to remind you, I've emphasized this. And it was actually last year was like the worst year. There were a bunch of students. I told them, oh, you can just move your place value because that's how I do it. And they end up getting every question wrong because they moved their place value wrong. So actually show the step, the students who showed the step. Now, this was something I emphasized. We still have more steps. When you solve for X, always identify it's a base. We're dealing with a base. So X is hydroxide. So when you do negative log of your X, that's going to be your POH. And then you change it to pH. All right. Either number your steps or make sure that it's moving in a linear function. Like I would have to number that once I got there. This is my third step. Well, I guess I did go somewhat linear. And there's our answer, 7.65. Oh, and as I mentioned at the very beginning, I love this question. Why does the answer make sense? Other than the teacher did it, we're working with the sodium saccharide as a weak base. Saccharide is a weak base. So pH should be greater than 7. It's not huge, but it is above 7. It's weak. And for those of you who've asked some really good questions, if you look, our KB value is going to be 10 to the negative 11.68. That's a really small KB value. When you start getting that small of an exponent, that's going to be a really, really weak base, which means our pH is just going to be barely above. If our KB was like 10 to negative 2, 10 to negative 3, that's a much stronger weak base, so our pH would be higher, like a 9 or a 10. To get very highly basic, we would have to have a strong base. All right, and just because it's really important, Le Chatelier's and just from past experience, I think in the online environment, the students have done better with Le Chatelier's because you can go back and rewatch that part of the video if you needed to, and so that whole lab. I don't know. So if we remove the hydrogen, all fairies are fine fairies, by the way. Some are just misunderstood. If we remove the hydrogen, then, and if it helps you put the brackets around the whole thing, it's got to shift towards the hydrogen. So it's going to go reverse. All right. They add more water. Oh, there we go. Nothing happens. Why? No change.
It's a liquid.
It is a liquid. So remember solids and liquids. That might be why I put this one on there, because I needed something with another state of matter. No change. Solids and liquids. If you add more, if we totally removed it, then we would have to do something because equilibrium means everything has to be present. All right. We increase the pressure. Those evil gremlins. You know the term gremlin is a chemistry term. Does anybody know where it came from? You would know if you did your paper on cobalt. Did anybody do their paper in 221 on cobalt? That would be a good one to email me about. Look up the history of cobalt, where it got its name. All right, Samara emailed me about the other one I offered. By the way, the term gnomes is a chemistry term. So like when your math teachers use it, they shouldn't get to, but chemists should, as well as gremlins. So if we increase the pressure, we have 4 moles. You're only looking at the gas and 1 mole. So a high pressure, it's going to shift it forward. It's going to push the gas together. So high pressure moves to the side with less moles. All right, and we're going to put it in ice. So ice or heat means we look at delta H. So that is saying the delta H is greater than 0. It's positive. It's endo. So heat is on the reactant side. So if you put it on heat, it's going to move towards the heat. It can help for a lot of students to write the heat in. Ice is going to move it in the exothermic direction because you need to make more heat. All right, questions? So Major, this is back to the one you'd asked me earlier. So this one it asks, we're going to increase the CO. So which ones are going to shift it reverse? And in the case of these, it was A and D. I mean, there are other ways to shift it reverse, but in the terms of the ones I gave you, A and D were the only ones that shifted it that way. And then temperature and pressure. So we don't want low temperature. Ice made it go the wrong way. So high temperature, because it's endothermic. Endothermic loves heat. And pressure, high pressure shifted forward. So high pressure, high temperature would shift it forward. Any questions? And you can all email me about gremlins and gnomes, or you can send me your favorite equilibrium or pH cartoon. So if you didn't get your bonus point on the board because you weren't here, you can email me a cartoon that has to do with either equilibrium or pH. You don't have to make your own unless you're Max, then you would have to make your own. But Max, how are you not on the board? You answered stuff. I think I thought you were already up there. I apologize. I think Damon answered multiple times too, and I finally caught him. I'm so used to both of you always being up there. Did Major, should we put Major's name up there? Probably. All right, I'm gonna stop. Major, you answered many